and welcome grade 11s to the Wavefronts task video. In this video, you can apply and practice some of the ideas you have learned in the 4 lessons. You will need your study notes for the Wavefront series, and you might want to watch the videos again. Here's the first question. Find this drawing of the 2-point sources in your series guide. Where does constructive and destructive interference occur? Use a colored pencil to join the points where constructive interference happens. The lines you draw are called the antinodal lines. Use a different colored pencil to join the points where destructive interference happens. The lines you draw are called the nodal lines. Did you manage to draw the nodal and antinodal lines? Good. Here's question 2. Look at this diagram, which shows where the first bright fringe is formed when orange light passes through a narrow slit. Use the relationship sine theta is equal to the wavelength lambda divided by the slit width w to calculate the wavelength of orange light. Theta is 1.2 degrees. Take sine 1.2 as 0.02. Slit width is 0.03 millimeters. You have adjusted the width of the slit to 0.03 millimeters wide and carefully measured the angle theta to the first bright fringe. You'll find that the angle is 1.2 degrees. Now you are able to work out the wavelength of the orange light. What answer do you get? CAPS exams might not require this kind of calculation, but it's good practice in working with trig ratios on your calculator. Notice how very small the slit is and how very short the wavelength of orange light is. Here's question 3. Orange light is diffracted and spreads out as it passes through that narrow slit. Sketch the diffraction pattern for orange light as you think it would look. You have seen a diffraction pattern for red light in the videos. Show at least 2 bright fringes on each side of the center bright line. Here's the final question. Imagine you kept the slit width the same but used blue light. Right underneath your sketch of the diffraction pattern for orange light, draw a diffraction pattern for blue light. Will the pattern look different to the one for orange light? If so, how will it look different? You'll find the answers to the questions in the Wavefronts series guide and on the Mindset website. Thank you for watching, and goodbye.